All right, you guys, here's the circles review sheet. Make sure you're very aware of these basic items here. There's really only one chord in this problem. It happens to be going from J to L. Since it goes to the center, that's also our diameter. A secant has to be a chord that keeps going. And this tangent, the lowercase letter, means that we can call that line M. Now, radii is actually asking for multiple radii. We have one from NK, from K to L, from J to K, all of those being segments. Chords, they're looking for more than one chord. I guess it said chords over there, but there's only one. On the test, you really only have to find one. So from Y to Z, as long as it stopped, I could have done WV as well. Oops, just need the line above. Secants would be from Y to Z, but yet it keeps going. Tangent, there's that lowercase letter line, N. And there's only one diameter. WV is the only chord going through the center. Several radii from WX, also XV. Problem 2, summit of Mount McKinley in Alaska is about 20,000. So they're talking about this mountain over here from E to D. The summit is about 20,321 feet above sea level. What is the distance from the summit, which would be point A, to the horizon? They want to know this measurement here. To the nearest mile. So we don't want feet. So we need to find out how many miles are. We're going to divide by 5,280. So let's see what the calculator says there. 20,321 divided by 5,280. The amount of miles we have is about 3.85 miles. And just understand that's from E to D, the mountain, the height of the mountain off the surface of the earth. So we have a right triangle. We know the radius of the earth is about 4,000 miles. So from E to C would be 4,000 plus 3.85, which is our hypotenuse. So we should be working this Pythagorean theorem problem. Okay. So I would end up subtracting whatever this is to the other side, so I can have the calculator do all of this work for me. If that makes sense. So that's what x squared would be. .8225. And I just want to square root that, which is the same thing as raising it to the 1/2 power. That's a little trick. So the answer here, so they want us to round to the nearest mile, so it'd be about 176 miles. They want us to find each measurement. Well, we've got a whole bunch of central angles here. This is 90. If that's 50, the rest of this has to be the rest of 90 degrees for 180. This is a vertical angle here, which means arc FB is 40 degrees because central angles equal their arc. BEC. So we're talking about BEC. Well, I got 180 plus 90 is 270. Again, feel free to pause, rewind, take a look at any of this that you need. Again, more central angles. Vertical angles, I got 82 degrees. Vertical angles, I got 35 degrees. 180. Well, 35 plus 82 is 117. I take that from 180. I got 63 degrees here. That means I got 63 degrees on the vertical angle. So arc FG, 63 degrees. FCA would be 180 plus 82. And they want us to find the length of the line segment JK. I think that's actually kicked from here. This other problem, we want to find the measure of JK. This is a tricky problem, but if we know that these two measurements are the same, they're both 8, which is a radius, which means this radius is also 16, 8 plus 8. I can find JK because I know if we have a perpendicular situation there, then it's cut in half. So I don't know, squared plus 8 squared equals 16 squared. I have a Pythagorean theorem problem right there. I think 16 squared is 256. Let's double check that. 256. Move 64 to the other side. Minus 64 is 192. And again, I can square root by raising that number to the 1/2 power. It's about 13.9. Ooh, but that was only 1/2. That was only 1/2. That's not my answer. I need to double that. 27.7. So here we moved from central to inscribed angles. You want to find the measure of angle ADB. This inscribed angle's got to be half of its arc, so that's 60 degrees. Arc CB, we got to go the other direction. We got to double that angle, which would also be 60 degrees. I think that says 30 there. More inscribed angles. Inscribed angle, inscribed angle, inscribed angle. Angle ABD. Its arc is 80. The angle's got to be half. The arc's got to be double. And again, whenever we have a chord and a tangent, we're going to treat this like an inscribed angle. The arc is 270. The angle will be half of that, which is 135 degrees. This is one of our formulas. This is not a central angle. There's the center. The vertex isn't at the center. But we can find these two angles by averaging the arcs that they face. That's 140 divided by 2, which is 70 degrees. Is that what they're looking for? AFB. No, they want this angle, which is a linear pair with those, which means the one I'm looking for is the other part of 180. Two pages down. We're flying. Bell's going to ring, so ignore that. We'll just keep working the review. Again, solve for x. These are tangents, so the total's got to be 360 if that's 150. That means I got 210 degrees here. The formula off the formula sheet says y degrees minus x degrees divided by 2 has to equal the angle out here. So that's 60 divided by 2, which is 30 degrees. Another one of the, hopefully you caught all that. Another one of the formulas. Gotta do this times this equals this times this. 4 times 12 equals 6 times x. 48 equals 6x divided by 6 on both sides. X is 8. Another application of the formula. Remember, the outside times the whole thing. 14 times 20 plus 14 has to equal the same thing on the other segment. 11 times 11 plus x. So on the left side, I got 34 times 14. And I distribute the 11 on the other side. 121 plus 11x. Move 121 to the other side. And I got 355 equals 11x. Divide both sides by 11. Hopefully I got all that right. 476 minus 121. 355. Just 32.3. It's not always a pretty answer, you guys. Notice all the work I'm having to do by hand, so try not to do this all digitally. Here's another one of our formulas. The outside times the whole thing. 2 plus 12 is 14 equals the tangent squared. 2 times 14 is 28. And we would square root both sides. So I could either say my answer is the square root of 28. If you remember simplifying a radical, it would be 2 square root of 7. Or technically, I could find the decimal and average, which would be about 5.3. These are all ways to communicate our answer. These two problems, very, very important. This is an inscribed angle. The inscribed angle's arc goes from here to here, which is half of the circle. It's 180 degrees. That means the angle's got to be half of that. So 3x minus 6 better equal 90 degrees. Add 6 to the other side. Divide by 3. I get 32. With an inscribed quadrilateral, what I communicated is that if I know if I have expressions for 2 of the angles across from each other, that means I have 2 inscribed angles. The arc for angle A would be a whole big part of the circle. The arc for angle D will always be the rest. If the arcs add up to 360, then those 2 inscribed angles better add up to half of that. Combine like terms. Add 2. And let's see, what is 182 divided by 7? 26, hot dog. This might be the last page? No, yep, last page. Hot dog, we're flying. Equations of circles. A lot of this is not so bad. Some of it's a little bit tough, okay? So I'm going to use the center. Remember the standard form, x minus h squared plus y minus k squared equals the radius squared. That's what our standard form should look like. So we plug in the center. X minus 3 squared plus y minus a negative 4 squared equals the radius squared. 5 squared is 25. Whoops, that's my answer. If I want a graph, I better find the center. So if this is x minus 2, I want 2. If there's y plus 3, I want to pull out that negative value. There's my center. And the radius squared. The radius had to be 3 to square to make 9. So we go 2 to the right, 3 down. And I just go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. There's going to help me draw a decent circle. Now comes the fun stuff. All right. Rewrite our equations into standard form. This is the stuff we covered in class about completing the square root. So step 1, isolate the variables. X squared plus 8x and leave a blank for c. Y squared minus 12y plus c. And I'm going to move that negative 12 to the other side. Then I want to find out what half of b was, which is 4, and I square it. So I'm going to throw 16 in there. Half of b was negative 6, and I square it, I get 36. But if I add 2 values to the left side of the equation, I better add those 2 values to the other side of the equation. Now, this will always factor into x and whatever half of b was, which is plus 4. Y and whatever half of b was. And 12 plus 16 is 28. 28 plus, that's 64. So that's my standard form. The center is going to be at negative 4, positive 6, and I square root this to find the radius is 8. Cool, let's practice again. Step 1, isolate the variables. Leave a blank for c. My new c, which we're going to complete the square to find out. And let's move the 85 to the other side. So it's going to be a negative 85 on the other side since it's positive. The only way to move it over there is to subtract it. Half of negative 10 was negative 5. If I square it, I get 25. Negative 5 times negative 5 is a positive 25. Half of b was 8. And if I square it, I get 64. But if I'm going to plug those in, I got to compensate also by doing the same thing on the other side. This should allow me to factor into x and whatever half of b was. Y and what half of b was. I got the 8 because half of 16 was 8. I got the negative 5 because half of negative 10 is negative 5. That's just how the factoring works every time. 89 and negative 85 will leave me with 4. Standard form, the center's got to be at 5, negative 8, and the square root of 4 is 2. Hope you've been practicing and watching all the videos, and I hope that makes sense. Remember to pause, rewind, rewatch, ask questions, communicate if you need any help. Otherwise, I hope you make an A on the test and get yourself up to that potential. Good luck.